It is internet of Hukamat. Internet is on what I wanted to. Can you please ask me for again? Only 2 hours. ಅದಾಗ್ಬಿಡ ಒಂದು 5 ನಿಮಿಷ. Okay, I will wait for another 5 minutes. There are only 13 viewers right now. Ask others to join fast.
Good morning. Okay, I will start. There are 30 users now, so I will start the class. So in the last class, we started discussing regarding this TCP/IP model or a TCP/IP protocol suite. Okay, we started discussing regarding this. Discussed regarding a physical layer. Okay, so this particular layer, as I said, it takes care regarding two major issues: mechanical procedure, another is electrical procedure. The issues that are related to mechanical and electrical, that is taken care by this particular layer. Say mechanical indicates what type of a connector to be used, how many pins should be there on the connectors, and what should be the length and size of the connector. All those issues are connected with mechanical procedures. And what kind of a signal representation we should use, okay, whether it is a Manchester encoding or differential Manchester encoding or your normal say 0 1 1 0 and 1 pattern. Okay, so there are say some different representation schemes that are in a use, so it will be decided, those issues will be taken care at the physical layer. Next we also discussed regarding the link layer. I'll just go through it. So I just talk regarding 5 functions of the link layer. Okay, so that is, first one is say framing. Yes, framing. The second task I said was say that physical addressing. Yes, third one is error control. And fourth is say flow control. Fifth one is access control. So these are the 5 tasks what we discussed in the last class. Okay, so today's discussion will be all about say the same thing. Actually, some student has say wanted to know regarding this link layer again. So I just go through it again. So I was talking regarding a link layer. I said that the link layer's job is to take care regarding the issues that are connected between the two ends of the link. Now you know, in the network, when it makes the two nodes to communicate with each other, yes, when we want to make two nodes to communicate with each other, what is needed is I need a support of some multiple devices. Okay, I need a support of some multiple devices. So today I am showing some variety of devices. In the last class I have shown only routers. Okay, so for understanding reason I have added another 2 devices. So I am going to call it as switch. This is my router, yes, or layer switch. Fine. And this is my, see, some of the terms which I am using here, so you may not say come across those things, but later once we start discussing details of these layers and all. That time we will come to know regarding some of these terms. Okay, layer 3 switch, layer 2 switch, all those details you will come to know in the later part. This is the introduction chapter. So where say it is difficult for you to digest everything in one shot. Okay, so first this node gets connected, reaching its destination through such multiple devices. Okay, that means the message that is generated by node 1 to reach node 2, it needs to go through multiple hops. So at every hop you are talking of new link. At every hop we are talking regarding a new link. So data link layer the data link layer will going to come into the picture. It will take care regarding those issues that what we have highlighted. Not all 5 issues will be taken care at one shot. Okay, in some situations it depends on the environment, kind of a network and all. Okay, so I have listed all the functions. Okay, but say when it comes to this link, so here the major concern is what about error and flow. So those 2 issues will going to be taken care over here. Access control will not going to be seen in all networks. Okay, it depends on what kind of a say technology we are using to propagate the message. So based on that, access control will going to come into the picture. Yesterday I told regarding that. Okay, so next is say whenever it pushes the message, okay, to reach this particular node, okay, say intermediate node, what is needed is we need a address of the switch. Okay, so physical address of the switch. So that is the reason why we talk of physical addressing, and the message what you are pushing or the information what is getting pushed by the link layer or provided by the link layer to the physical layer, which will be in the form of frame. Okay, so this frame will be made to travel through this link to this intermediate device. Again, see, while this frame is traveling from this node to this node, the address what it carries is the address of this node, physical address of this node N1 and physical address of switch S1. Okay, normally these type of intermediate devices, they have a multiple physical addresses. Okay, every interface will go to have a new physical address. Every new interface in the say thing in this nodes or these intermediate devices, they have a different address. Okay, every interface will be identified by different address. Now see, so when the frame moves from here to here, it will bear a physical address that is N1 and S1. Now see, I am just understanding reason I am using the terms N1, S1. I am calling them as a physical address. The physical address that frame this base is N1 and S1. So N1 is sender's address, S1 is receiver's address. Clear? So once it reaches this switch S1, okay, it is required to be forwarded over here. Okay, now from here to here, the address will going to be changed in the frame. The same frame, content of the frame will going to remain as it is. Only the header part will be modified. Okay, so in the last discussion, I also told you regarding the same. So the frame contains 2 parts. The first part we call it as header part, which contains control information. Most of the time, the control information will going to be filled in this header part. Okay, one of the control information is these addresses. Okay, so these physical senders and receivers address is part of this control information. Yes, and the other part of this frame is payload part. Okay, which carries the data that comes from the higher layer. Okay, so in these nodes, the data that comes from the higher layer is normally it is from the network layer. So the network layer data what it gets, okay, so on sending machine, that will be dumped over here, and the physical address will be put over here, and the frame is made to send. So when a frame is moving from N1 to S1, the physical address put over here is N1 and S1, and while it is leaving this switch and heading towards the router, that time this interface address, for timing I will take it as S12. Okay, I will take it as S12. That is a physical address of this link, this side of the link. See, there are two interfaces, this interface and this interface. Okay, so these two interfaces have a two different addresses. Okay, these two interfaces have a two different addresses. This is S1, this is S2. I hope it is clear. So, one second. Hey Ishan, what's up? Charger ko, laptop charger. Okay, so this is S12. The physical address of this interface is S12, and the physical address of this I am going to call it as R1. R1. So when a frame is moving from this switch to this router, the physical address gets changed to a R1. S12 and R1. See, earlier the physical address was N1 S1, and when it starts moving from this end to this end, the address gets changed to S12 R1. Yes. So when it comes to the next hop, okay, when it comes to a next hop, again that physical address gets changed. Okay, so the new physical address will go to be what? It is R1. So now I'm going to call that address as R12. I'm going to call that address as R12. 1 second. Okay, I'm going to call this as R12, and this I'm going to call it as S2. So when it is moving from here to here, the address gets changed. That is new address, that is R12 and S2. Now see, at every hop, one thing is observed, the physical address is getting changed. Physical address is getting changed. Say from this hop to this hop, the physical address is different. From this hop to this hop, physical address is different. So at every hop, the address gets changed. Okay. Now this is what is a physical layer. Okay. I mean link layer. So this is what is the address that is provided by the link layer. So look at the term link or a data link layer. So basically it is connected with the issues to be addressed between links. Between two ends of the links, okay, so basically it is connected with addressing the issues that are between two ends of the links. Okay, so whatever the error control it is taking care, so all those issues are between those two ends of the link. Okay, now normally in link layer, okay, what they do is they use a technique, say, of error correction or error detection. Okay, say we use a technique of error correction or error detection. Okay, so these are two different issues. I think you might have been discussed a parity bit technique of, say, error detection. Okay, normally in internet, okay, error correction technique at a link layer will not be that widely used. Okay, when it comes to correcting of error, we need more redundancy bits. Redundancy here indicates we need to add additional bits apart from the actual bits that data represents. We need the support of some additional bits. So that means your overhead increases here. Okay, you are adding additional unnecessary bits apart from the data. So these additional bits will consume some space. So naturally the frame data carrying capacity will go to be reduced. So this overhead, to avoid the overheads, okay, what we do is normally error correction technique is not preferred. Okay, normally in the internet error detection technique is widely used. Okay, so whenever some error gets noticed, okay, so that is a method of, say, calling it as error detection technique. So if some error is noticed at a receiving side, what it will do? It will simply drop that frame. It will simply drop that frame, and automatically there is a mechanism involved in the data link layer. Say it will come to know that dropped frame and it will reset the same frame. So this is how they take care regarding the error. So whenever a receiver drops the frame because of error, yes, that will be known to sender. Some mechanism is involved that we're going to discuss in the later part. Okay, so then what sender will do? So once it gets to know regarding the say dropping of the frame, what it will do is it will resend the same frame. It will resend the same frame. This is how the error correction takes place. Okay, so this method is widely preferred. So in another technique, say whenever a frame arrives at a receiving side, okay, it detects for an error. If error is noticed, the receiver itself will try to correct the error. Okay, for that, as I said, it needs a support of more bits. It needs a support of more additional, say, redundancy bits. Those redundancy bits, we call them as a parity bits. It needs the support of more parity bits. Okay, so these parity bits are overhead. So the correction method at a receiving side is not preferred. Okay, error detection only will be done by receiver, and automatically correction is taken care by sender. Okay, so this is preferred widely in the internet, say, world. Okay, next layer is your network layer. Okay, now look at the task that network layer performs. Okay, now we talked regarding going to a destination. Okay, I said that when it comes to send the data from N1 to N2, okay, so if it is far away from source, it selects the say multiple hop path to reach the destination. Is it clear? So in the internet, there is a possibility that these type of paths, there may be many such paths to reach a destination. Okay, because internet means what it is? It is connection of it is a collection of interconnected networks. Collection of interconnected network. Okay, so internet means it involves everything. Say LAN, WAN, yes. Multiple such networks are interconnected to create a or to form a internet. So when we are talking of interconnecting such a multiple networks, naturally there will be a multiple paths exist to reach some destination in the internet. Say whenever I talk about the two nodes, naturally to reach those from one node to another node, there will be a multiple paths exist. Okay, so out of these multiple paths, so I'll just redraw that thing. Okay, say I'll show you this by using some kind of a graph. Okay, now imagine this is what is the paths that are available to reach destination. So I'll call this as my N2, this as my N1. Now from N1 to N2 to reach from N1 to N2, now you look at this figure. Okay, here we have multiple paths. Okay, so this part many a time we call it as subnet. We call it as subnet. Okay, normally these subnets are created by using these type of devices, routers and switches. Okay, so now these subnets normally it offers a multiple paths to reach a destination because there are multiple paths available. Now it's a job of sender to select one best path to reach a destination. Okay, it's a job of a sender to select one best path to reach a destination. Clear? So that selection of path, through which path it has to go to a destination. Yes, that selection of some specific path to reach a destination is done by network layer. Okay, whether this path is suitable or this path is suitable or this path is suitable, that is taken care by network layer. That it will decide. Okay, so normally it is equipped with say network layer, say offer some different type of routing algorithms. So with the help of those routing algorithms, paths will be decided to reach destination. Okay, so which path to be used is going to be decided by sender. Okay, with the help of routing algorithms. So that is the first task of network layer. Yes, first task of network layer, that I am going to call it as routing. Yes, so it decides which route to be used. Yes, now to decide which route to be used to reach a destination, first it should know destination with which it is communicating. Yes, we need some kind of identification for destination at this layer also. In the physical layer, I was talking regarding the physical address, that is an identity that is used in the physical layer, I mean link layer. So I was talking regarding a link layer. We need some kind of a identification at the link layer to identify the source and the destination. So for that we use a physical addressing scheme. Okay, when it comes to network layer, okay, we need some kind of identification at network layer to identify source and destination. So again, the second task of this network layer is addressing. Okay, so now see, in the beginning itself, in one of the class, I told you regarding, say, network layer entity is only capable to communicate with network layer entity on the other side. So even though the question arises whenever there is a physical address, why to use some of newer addressing, it is mainly because that, say, network layer only capable to communicate with network layer entity on the other side. Okay, so for that it needs a support of addressing. Okay, so what kind of addressing it uses? That addressing we call it as logical addressing. Okay, logical addressing. Okay, so these are logical addresses. So if I talk about the specifically about this TCP IP protocol suite, these addresses we call them as, say, IP addresses. Okay, so you see these IP addresses are meant for identification of these end devices. Okay, so whenever N1 wants to decide to reach N2, it should know the IP address of N2. Yes, so it should know the IP address of N2. This is what is the condition. Okay, so assume that it knows the IP address of N2. Okay, once it knows the IP address of N2, with the help of that IP address, it will decide which path to be used to reach N2. Okay, so there will be 3 paths. Out of that, it will going to select the best path. Normally, there are some different kinds of a matrix which will be used to decide the path. Okay, so one of the matrix that is used to decide which path is best is the shortest path method. I think you have come across some different kinds of, you might have discussed some different, say, algorithms which helps you to find the shortest path in a given graph. Now if you see, when you look at this, it is something like a graph with some nodes and links. So finding the shortest path using those algorithms. Okay, so actually your job is to find the shortest path to reach destination here. So destination is now identified by what? It is identified by logical address. Yes, so that means the logical address that sender should know before reaching the destination. So logical address of receiver should be known to sender to reach receiver. Is it clear? Okay, so I will also discuss regarding how exactly N1 will come to know regarding the logical address of N2. Okay, that will be again one more question that we will see to it later, because once I finish all discussing all these, say, layers, I'll go back. I'll discuss regarding that how some nodes will going to get the logical addresses. Okay. Now in this case, what happened? It should know logical address. Now the question arises. Okay, once it knows the logical address, it will decide the path to be selected. Now see, we will try to combine the data link layer task and the physical layer, this network layer task, and we will try to analyze the same thing again. Now see, network layer which comes before link layer, which is sitting on the link layer, it takes the services of link layer to perform its task. look at the term I am using. Say I am saying network layer takes the services of link layer and it tries to reach the destination. Is it clear? Is it clear? Okay. Now, in this case, yes, we'll see how exactly it reaches. Say first, it finds the path to reach N2 with the help of some routing algorithms. Yes, it finds a suitable path to reach N2 with the help of routing algorithm and with the help of IP address. Okay, so these IP addresses will going to be put in the message that is created by network layer. Okay, these IP addresses which are obtained with the help of routing algorithms will be used as, say, information to reach destination. So naturally, whatever the message that is created by the network layer, okay, it also contains header. It also contains header along with payload. Along with payload. Now, from where exactly it gets this payload? Whether the network layer generates on its own or whether it gets it from somewhere else. For a time being, you consider that this payload comes from higher layer. Higher layer. Which is the higher layer here? It is the transport layer. Transport layer is the one which will going to provide this payload content. What is to be put into it is going to be provided by transport layer. Okay, so it takes the payload and puts it over here and it puts its own control information in this header. Okay, one of the control information that what it puts over here is IP address or logical address. Logical address. I hope it is clear. Yes, this particular address will going to be dumped over here. Clear? So these addresses later makes this packet to move on a specific path which was decided by this network layer only. Yes, to reach destination. Clear? To reach destination. Now, this particular address which is put over here. So, which address we are putting over here? Logical address of N1, logical address of N2. Yes, this particular address is generated by whom? N1. Yes, these are the things which are put into this, say, message by whom? N1. Yes, then it sends this message through the path which is decided well in advance. Okay, so these paths will be used to reach some destination. Say here in this case it is N2. So whatever the message that it creates, it travels through some specific path to reach N2. Okay, now I am using the term message here. Okay, so this message which is generated by N1, we call it as packet. We call it as packet. Look at the term, huh? So in the link layer, I was using a term frame. Here I am using the term packet. Okay, packet is the one which is created by your network. Message what network layer creates, we call it as packet. As usual, packet contains two parts. One is header part, another is payload part. Payload carries the data from higher layer. Yes, header part contains the control information which is needed for network layer along with the logical address. Clear? In a TCP/IP model, the length of this logical address is 32 bits. How much it is? 32 bits. It is 32 bit. Yes, you are free to give your comments in WhatsApp. Huh? See, because here two-way interaction is not possible. It is a simplex kind of a communication where I have to speak, you have to receive it. Okay. If you had any doubts, if you had any issue, please say answer or say reply to me using your WhatsApp. So I am available on WhatsApp. My WhatsApp is already say on over here. I can see your comments. Okay. you are free to give your comments through WhatsApp. Okay, anyway, we have created the DC group. Okay, just put your comments in that DC group. I will try to answer, I will try to solve your problems. Okay, anyway, I will go to give 3 to 4 minutes at the end, so that if you had any doubts and all, you are free to ask. Yes, so this is 32-bit number. Okay, this IP address, but this 32-bit number was used in a older version of IP. Okay, internet protocol. So it was say 32-bit. Nowadays, you know, each and every mobiles are also connected to internet, and we are talking about internet of things, IoTs. Even we are planning to control our fan, AC, all the devices on the earth with the help of internet. Okay, so for that, this 32-bit length of an address is not sufficient. Okay, so in the higher version, that is version 6, there is no version 5. Okay, directly they moved from version 4 to version 6. So in this version 6, the length of this IP address or logical address is 128 bits. It's 128 bits. You see, directly it is changed from 32 to 128. Okay, and your link layer address, that physical address. Okay, in TCP/IP model. Okay, if you are using a IEEE 802.3 standard. Okay, so it depends on the say protocol what you are using in the link layer. So that is the reason why I have not say discussed more about it. Okay, I'll come back to it in the later part. For time being, you take it as 48 bit. For time being, you take it as 48 bit. Yesterday I explained you taking an example of our say college Wi-Fi. So there you need to provide this 48-bit address, physical address to our server room people. They will allow you to access the internet by authenticating you using this address. Okay, so this is link layer address, and the network layer address is 32-bit or 128 bits. Okay, I told you the length of the address in terms of bits. Now I hope it is clear. Okay, now two things, it performs a routing and it will also performs addressing. Addressing is going to be done by this network layer. So routing is job of finding the specific path to reach destination. Now see, what we did is we know the technique of reaching from this node to this node with the help of network layer. But still task is not accomplished. Look at the way in which we are decimating or dividing the tasks. Okay, in link layer we talked of hopping from one link to another end of the link. Network layer we are talking of hopping from this node to this node. Fine. Now still we have not yet accomplished the task. Just I will give you one analogy. Okay, say whenever somebody sends you a mail, okay, this postal mail, okay, if he writes only your surname on that envelope, okay, if he writes only surname on that envelope along with say specific location, address and all, who will going to receive that? In your house, say for example reason you take, in your house there are 5 members and some letter comes to your house bearing your location details and only surname on envelope. That means this particular letter is meant for whom? That information is absent over here. Only surname is there. I am not talking about the name. I am only talking about the surname which is present on the envelope. So who will going to receive this particular say mail in your house? Because nobody's name is mentioned over there. So that means there is a possibility that one of these 5 may get this. Okay, the information in this mail is meant for one of the 5 members of this house. How to identify these members? For that, the technique what we use is we use names. So name along with the surname helps us to identify the specific person in the house. Okay, so this IP address is something like assigning the surname to the envelope and sending the mail to destination. Now we need to add that one more say thing to this surname, that is name. We need to identify specific process which wants to receive this message. Okay, specific process. Look at the thing. So now I will talk regarding transport layer. Okay, transport layer. So in this particular layer, okay, the task this particular layer required to perform is to identify the process which is sitting on different nodes. Okay, now the process on N1, process N1 wants to communicate with the process N2. That means we are talking of N1 has a capability to communicate multiple processes simultaneously. This is what normally happens when you sit for surfing. Yes, whenever you click on a say browser, okay, you have an option of opening a multiple browsers at a same time. You are typing different URLs in the browsers. You are trying to reach different sites simultaneously. Yes, so that means you are trying to communicate with different processes. Say for example, there is a possibility that you are communicating with a different process which is running on the same machine. So here N2, you are talking about some process which is running on N2, specific process. There is a possibility that one more process which is running over here, which is communicating with one of the process which is running on N1. Now to identify these specific processes, we need some kind of a mechanism. IP address helps us to reach only this. From here to here, to reach from here to here, IP address helps us. IP address helps us. But from here to reach specific process, what I need? I need some new address. That new address, what we call it as, say, process ID. Okay, we call it as process ID or transport layer address. Okay, say sometimes we also use say other terms will come whenever we come across that particular time. I'll talk regarding that rather than talking everything now itself, because it is an introduction chapter. So all the details I am not going to talk here now. I'll postpone it. Okay. So for time being, the process will going to be identified by process ID. Okay. So this process ID will going to be provided by transport layer. Now see, whole hierarchy you see. Process ID is needed to identify process. Network address is needed to identify machine. Link layer address is needed to move from one link to another link. So this is how the addressing hierarchy is used to reach the destination and specific process. So the job of this transport layer is to provide addressing. Okay, is to provide addressing. Okay, so same as that of your network layer. Okay, the second task, what it requires to perform, say it is specific to TCP/IP model. It is specific to TCP/IP model. The second task, apart from addressing, yes, the job it will go to perform is error control. Now see, I am repeating the things that what I have discussed in the link layer. So error control. Next task is flow control. Okay, flow control. I will add one more control to this, that is congestion control. Okay, third thing is congestion control. So addressing, error control, flow control and congestion control. Is it clear? Now the question arises, when a link layer is performing error control operation and link layer is taking care of flow control, why we need say one more say layer to perform the same task? You are repeating the task. So same task is getting performed by another layer. It's a kind of a repetition. Yes. So now, what is the use of these things at transport layer? That question arises. Okay. So the thing is, the problem with the transport layer. Okay. The issues that is addressing by the transport layer is global issues. Now see, when I talk about two nodes which are running with the processes which are running on these two nodes, which are reached by with the help of multiple things. So transport layer addresses the issues between two processes. Two processes. This error control, flow control, congestion control, that is taking place between two processes. It is not between two links, or it is not between two nodes. It is an issue between two links. Okay, I mean two processes. Okay, so it is taken care by transport layer. So that is why we call it as these issues are global when it comes to the transport layer, and when it comes to the link layer, same thing, error control, flow control, say access control, that is local issue. That is local issue. So it is an issue between two ends of the link, that is local, whereas the same thing which we are talking in a transport layer, they are global. Okay, so they are global. I hope it is clear to you people till now what we have discussed. Okay, so now what way the data is going to be represented in the transport layer, that is also one more issue. Okay, so apart from addressing, okay, we need some way of representation of the message. Okay, so the information that is generated at the transport layer, we call it as segment. Yes, we call it as segment. I hope it is clear. We call it as segment. So this segment as usual contain two parts. One is header part, another is payload part. So payload contains the information that comes from the higher layer, that comes from the application layer. Okay, so whatever the message that is generated by the application layer, first it is handed over to the transport layer, that will be divided into a smaller units known as segments. Smaller units known as segments. Okay, so these segments contain two things. One is the message part, the second is header part, that is the control information that is added by the transport layer. Okay, so we need some supporting fields to carry out the tasks of error control, flow control, and congestion control. Those supporting fields along with addressing fields. So it will also provide addressing. Okay, in TCP IP model, the length of this transport layer address is 16 bits. 16 bits. Okay, so these 16-bit numbers or port numbers, this is what I was wanted to talk. So sometimes the transport layer address is also called as a port address. So 16-bit number or that port number, or a say process ID which is of 16-bit length, we use it in transport layer in a TCP IP model. Okay, so that means 2 raised to 16 different processes it can handle. Okay, 2 raised to 16 different processes it can address using this 16-bit length. That is 65,000 processes it is capable to address. Okay, now I wanted to add some more things to this discussion. Yes, so I was talking regarding port ID. Yes, port ID is basically say some way of identifying the process. Okay, so next there are certain processes, popular processes, such as your HTTP, Hypertext Transfer Protocol. Say whenever you are typing a URL, www.google.com. Yes, so you are not providing any number over there, but very easily you are reaching the Google server. Yes. So normally all of them are of the type HTTP. Most of the say processes that are in a use in the internet, see what we use, okay, for our daily activity are of the type HTTP, hypertext transfer protocol. So nowadays HTTP, yes, that security issue is also added to it. Okay, so to identify this HTTP on server machine, we know what we should know, the port number to which this HTTP process is sitting or connected. Okay, so this process on the server machine will going to be identified by what? Port number. Now whenever client machine N1 wants to communicate with say some server process which is HTTP process, so this process has to be get connected itself to some specific port so that the process on N1 communicate with HTTP. Yes, that port number for HTTP is fixed. So no matter on which server you are installing this HTTP, okay, so it will be get connected itself to a port number 80. So here we don't need a specific newer mechanism to identify this HTTP to which port it is connected. So that means based on say these standard processes, the ports are already assigned. So whenever you are saying HTTP, the sender machine will automatically convert that say HTTP to 80, and that message whatever the transport layer segment it creates, in that the process ID or process address will be put as 80. Okay. Similarly, there are certain standard ports, okay, for standard processes. For FTP also some port is fixed. Yes, even for SMTP, because all these are standard one. Okay, for SMTP some port is fixed. Okay, like this for a standard processes port numbers are fixed. Those ports are meant only for those standard processes. No other process is allowed to use those port numbers. This is how that addressing issue of transport layer is solved in the TCP/IP model. Okay, last layer, I am going to discuss this in the next class, because if I start discussing it, I need some more time. Okay, now almost it is 9:50. After this, you have one more class. So now I will give you a time regarding say your issues. If you had any problems or say difficulties, you are free to ask. Say please, you are free to ask your difficulties. I am there on WhatsApp. Any doubts? Please, if you had any doubts or any problems, you are free to ask. The quality of streaming, please give me a feedback. It was good or it is same as that what we faced in yesterday's class. Vaibhavi, please answer. Please tell me, how was the quality? Whether you face the same issue, same problem that what we have faced in the yesterday's class? Thank you. So now I will end the discussion over here. Okay. Anytime you are free to communicate with me through WhatsApp. Yes. Now I will end the discussion here. So we'll discuss the other layer and I will go through again all these layer details in the next class. Now I will end. Thank you very much. There are totally 48 students. Please, all of you, write your USN in comment section. Comment section. In comment section, you enter your USN. Only you enter your USN. No, I don't want other detail. So that I can note down your attendance. You enter your USN in comment section. One small request to you all, please like this video so that I can get like or dislike, whatever it may be. Yes, so it will be helpful for me to stream it directly. Right now I am using a support of some app to stream it. Yes, so if I get more views and say likes, so I think I am allowed to stream it directly through YouTube.